How's it going, Vaqueros? All right, so what we're doing next is we will be tackling page 73 in our traits and reproduction spider book that we have been using, and page 73 once again. And Mr. Lopez, I'm going to use a pen. I don't like to use pens because I might make a mistake, but let's do it anyways. Let's live dangerously. We're on page 73, and what we're doing is we're gathering evidence from our sim, and we're going to be looking at body color, and we will be examining traits and the different combinations of gene versions where we're going to be mating to spiders. First thing we're going to do is we're going to be launching the sim and pressing body color to observe Otis and Anne's traits. That's the first thing we're going to do, and we're going to need our simulation. So this is our simulation right here, and we click on the hamburger, as we call it, or the global navigation bar with the 3 lines on the top left, and look for our traits and reproduction simulation. So here we have it. This simulation right here is where we will be looking at Otis and Anne. We're going to be focused on those 2 spiders, and we're going to be observing their traits and also recording their gene versions. We're going to be recording their gene versions. So it says here, press. So we have a pen here. It says here to mate Otis with Anne by moving Anne over Otis until a dotted circle appears. So let's do that. So we have Otis and Anne. So in order to mate Otis with Anne, we have to make sure that Otis is a male and Anne is a female. So we can mate both spiders, and that is what we will do. So we will grab Otis.
We are now clearing our second floor to lunch. The 1235 second floor, A and B building are being cleared to lunch. 6th graders for the NPR.
And I'm recording, and Miss Diaz is stopping by. Hello, Miss Diaz. So I'm going to be clicking, and we have Dr. Mata. Okay, looks like the announcement is over. So we're going to grab Otis, and we're going to mate it with Anne by dragging it, and then this will appear. Okay. Now what we're focused on is their body color. So it says here, press body color. So we're going to click on body color, and here we have the gene versions for both spiders. We have Otis that has C1 and C3. So let me just write that here. This may do me a bit of good to just write it here on the side. And Otis is brown in color, and Anne is colorless. She doesn't have a color, and she is a C3, C3. C3, C3. It's the same gene version, right? C3 and C3. It's the same gene version. So that should hint at something. They are the same, right? They are the same gene version, which means they are homozygous. And I'm just going to write homo here because it's too long for me to write that. But homozygous, and these gene versions, C1 and C3, are different, right? DIFF. They are different. So what scientific term do we use? Heterozygous. So we have homo and heterozygous. Now, let's make our way to, well, C1 and C1, C3, and C3, C3. So we have to memorize that. Let me write that down. Otis, C1, C3, and C3, C3. So we're going to go here, and we're going to write that down. Otis, C1, C3, and Anne has a C3, C3. Their traits. Otis is brown. So we're just looking at traits. If we're looking at traits, Otis is brown and Anne is colorless. All of the information is here. All we're doing is taking the data and we're plugging it into a table. So brown and colorless. And let's go back. Otis is brown and is colorless.
Good afternoon again. Dr. Mata, for the third time. We are now releasing our first floor to lunch. It's around 12:39. In a few seconds it'll take you to get there. It will start. Lunch will start. So again, 12:40. Please start moving your students to lunch for the first floor. NPR 6th grade, 7th grade is cafeteria, and again, 8th grade is the variety, the ones right next to 118 with them. Thank you very much. Enjoy your lunch.
Okay, so now we are pressing create reproductive cells, and we are going to be randomly fertilizing these eggs to come together to create new offspring. All right. And I'm going to show you how to do that in the simulation. We're going to come here and we're going to click on this create reproductive cells. So we're going to click here, and they are now producing cells, and we are going to, so we have sperm cells from the male and egg cells from the female, and we're going to click randomly fertilize. Did you notice we had that option there to mutate as well? And there we are. So these two spiders created offspring. They had 4 babies, and we see them here: spider 1, spider 2, spider 3, and spider 4. I guess if we can make some observations, some observations here. Did any spiders end up looking like Otis? Any of Otis, Otis being the father? No. I guess you can maybe say this was the closest spider that ended up looking like Otis, right? They have the same color, but they don't have the same stripe color. And what about for Anne? Wow, look. Spider number 4 ended up looking exactly like Anne, the same color, and the same, also carrying the same gene version. But if you do notice, there is more hair on Anne than spider number 4's the offspring. So they are not the same, but they do have the same color. C3, C3. Also, and color, same. Gene versions, C3, 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 C3. So let's go here, and all we're going to do is plug this information in. Let's zoom in a bit. Because all we're going to do is focus on offspring number 1, gene version from Otis. So what gene versions from offspring 1 were handed down from Otis? So we're just focused on spider number 1. We're not focused on any other spider. And we're focused on the gene version. Which gene versions were carried from Otis to spider number 1? If we look closely here, we have C1, C3, C3, C3. So we do have this one that is the same, C3 and C3. So let's write that down. C3. Gene version from N would have been the same, C3. What gene versions did spider 1 end up with? C3, C3. This is the answer, C3, C3. So we click there. And what color is offspring number 1? Offspring number 1 is what color? Colorless, right? All right, so we're going to click here and we're going to write colorless. And let's look for offspring number 2. Offspring number 2, and we're looking at the gene versions that were handed down from Otis. We have C1, these are the gene versions, C1 and C3, and C1 and C3. Which gene versions were handed down? Looks like C1 is a connection, right? So we're going to write C1. And the gene version that was handed from the mother N was C3. And what is the gene version? All we're doing is taking these two and we're copying them and putting them here. C1, C3, and the color of the spider is brown. Now we're going to take a look at offspring 3, and we're going to be looking at its gene traits. And what we want to know is where did this protein molecule, where did this protein version come from? Gene version. This protein gene version, C3, did come from Otis. And C3 came from the mother N. There is one gene version, one copy that is handed down from your mother, and another gene copy that's handed down from your father. One from your mother, one from your father. C3, C3. And all we do here for the gene versions is copy both of these. So I hope you're noticing the pattern. And the trait, the color of our spider is clear, right? Colorless. And offspring number 4 is our last spider that we're going to talk about, and it is a colorless. It's the same gene version as this, this, and this. And C3 came from its father, and C3 came from its mother. So C3, C3. And it is also colorless. All right, folks, and that's about it. You guys did a great job. You did fantastic. And if you didn't quite understand, we're going to be doing another activity in which we're going to be looking at different traits. And you will get this. You will get it. All right, vaqueros, have a good one.